next class. I'll be right there if you want to join.
Twitch.tv/VGDC. Let's see, VGDC UCI. Let's see if it's actually working. Oh god, there's ads. Why is there ads on our Twitch? What? No, skip survey. Fuck that. No.
Money. This ad's Twitch.
Okay. So that all works. So hopefully that sounds okay. I'm not going to be playing game audio or anything. So we have we're going to start probably in 15 minutes. I keep on getting confused which is like my mouse and which is the TV's mouse. But yeah, we're going to start in 15 because there's probably going to be people who are late because they're getting out of classes. So how's everyone's day? Anyone have any good KFC lately?
KFC.
All I've had is Popeyes. Really? I've never liked Popeyes. I've never understood Popeyes.
Everyone's honestly. Raisin Cane's.
Raisin Cane's is really good. It's overrated, but very good.
Yeah. You should try checking it out. It's just KFC's so good.
Yeah, KFC's really gross. Like, I never want to eat KFC chicken anymore. KFC. Also, if anyone's in the chat, please talk so I know that shit's actually popping off and people know that. Okay, did it pause on my stream?
Did you announce this workshop?
I am. Oh yeah, I should probably do that. I should probably have announced this workshop.
Oh yeah.
Well, I announced it now. It's been announced in the VGDC chats. It's okay. It's okay. As long as it was in the email and everywhere else, it'll be fine. Sorry. That was actually very high school.
What were you doing?
Help me inside. How many of you have done shoes?
I didn't go down.
What?
I didn't go down.
Oh, okay. Most of the stuff will stay the same. Well, the underlying logic will stay the same. The words are... No one else has done shoes. I'm hoping... It's fun because I posted this in the SGDA chats, and I'm kind of hoping that like people from like Ohio State or like Washington are kind of emailing, tune in, and then one of them is like, "You're an idiot. You're explaining this wrong." Like,
Make sure to address like the audience online because whenever they're like this and this,
well, I'm
like,
gonna.
what the fuck are you talking about?
I'm gonna use the mouse. I understand that much. So
Use the pointer.
oh, I can't point a pointer at the TV screen and have it show up on stream.
Just
Not
pointer
that,
on the
dude.
slideshows.
Wait, what pointer? Where? Pointer? Oh.
Oh.
Sick. But this slideshow is 1, 2, 3, 4, 5, 6, 6 slides long.
It doesn't matter this one, but like I've seen other people just like just like refer to pictures as this. Come on.
I mean, like this shader, like we're gonna spend most of our time in Unity. So, and then by the end, I kind of hope that everyone is like doing stuff inside of Unity. Hopefully, knock, knock, knock. People coming into the game lab. Luis, did you knock back?
Hi. Hey, good. I'm glad I knocked back. I was trying to kill you.
If there's anyone in the chat, please comment. I don't want to feel alone in this room full of other people.
Join the chat.
You don't need to join the chat.
Just join the chat while you're here.
Oh, Derek can't watch the. It should be archived. It's gonna be starting proper probably at 6:05. So hopefully this all goes well. But yeah. Also, tell me if everything is mixed okay on the stream. I can't actually hear anything, so.
Wait, I can't hear anything.
Well, I mean, I'm talking to the 3 people who are theoretically in stream. I don't know if they're actually there.
It's live.
Twitch just gives you a number, and sometimes I have a strange feeling it's actually lying to you.
Is it already recording?
It should be already recording. I'm gonna have to ask someone to go into the YouTube video and cut this.
Wait.
Cut it. Now it's in. But yeah. It's really nice because on the stream you're actually getting a better experience than you are in person because this TV is so terrible. But yeah.
Why there are so many points on the screen? Is that shader?
God, I wish. I wish the amount of stars on the screen was a shader. I wish it wasn't just this TV dying a horrible death. Hello.
So it's like
We're gonna be starting in about 8 minutes, so. It's gonna be so weird because I'm gonna be talking to people on the stream, and it's gonna be like, who are you talking to, Itai? Why are you talking to these people, these internet people?
Don't forget to sub and don't forget to like, subscribe, hit that bell.
It's on Twitch. Wait, is it also on YouTube?
Make a bad screen shader. Wait, who is this? Is this someone in the room?
No, he's not
Oh,
here.
that's
It's
What?
Johan.
Is Johan? Ah, okay.
Where is
Hi, Johan.
Read it.
I didn't know that was Johan.
I think it's Johan.
Is it Johan? A bad screen shader? I mean, I could make post-processing effect. Y'all get out of this stream. You're here in person. You don't need to be in the stream. Da-da-da. Damn.
What does 07 mean? Oh.
Do we have string
Why?
thingies? No, we don't. We have a Destructoid, Mr. Destructoid. Why is that? Ah, yeah. We gonna blow up. Yeah, I'll probably also be teaching how to make a sprite shader. I should have done that first. I should practice doing that because I need to do that. Alright, 5:59. Minutes to midnight.
Are you gonna be working in 2D or 3D?
Primarily 3D, and then I'm probably going to do a 2D talk because a lot of it is the same. It's just like 2 or 3 little extra things that you have to be careful of, little gotchas that are very much Unity specific in my mind anyway. Where it's just like, hey, you know, make sure you set the tags right, set the blending right, and I can probably go over that really quickly. It's just been a while. The last time I had to make a sprite shader, that was horrendous because Brian was using a surface shader instead of a unlit, and he was like, hey, Itai, how do you do this? And I'm like, dude, it's been months, I don't know. And then I spent like an agonizing hour at a potluck. This was at a potluck, trying to get my friend's shader to work. And I was just like, I hate everything. I hate this. I hate that. Why is it like this? Why'd you do this? And then eventually I'm like, oh, right, the tags. And like after like messing with the tags for like just a tiny bit of time, it was like, oh, it works. And I was like, man, 2D shaders are whack. Why would you do this? But yeah. All right, so we're at 6 o'clock. Should we just start? Or should we wait for just a couple more stragglers? Stragglers isn't the word.
It's barely 6.
Yeah, it's already 6. All right, you know what? Let's just get this gravy train rolling. All right, so cool. Shader time. How many of you? I should introduce myself. Hello, I'm Itai. I'm the previous president. I was disgraced and ousted like 3 weeks ago. They're waiting to. They're mail ordering the guillotine right now. It'll be okay.
That's not on the budget.
Yeah, it's not in the budget. So how many of you know what a shader is? Vaguely. How many of you have messed around with shaders before? Okay, that's fine. It took me 9 months to learn shaders. Learn is a strong word. Shaders are... Someone at the door. I know I should have waited. Yep. All right, so shaders are what I call the highest level of programmer art, purely because most of it is through programming and just procedural stuff. However, I spent 9 months so that you don't have to spend 9 months. So I'm going to be trying to teach that and get some of the weird, abstract, obfuscated stuff out of the way, which is probably going to be most of this talk, and then a little bit into next time's talk as well. So, high-level programmer art. So, what the fuck is a shader? So it's a lot of things. That term kind of came from a time when on older graphics cards they had a set amount of shaders. They would say, hey, here's the glass shader, here is like the wall or like opaque geometry shader, and people would essentially all have the same set of shaders. Sometime around the mid-2000s though, we got to a point where we could compile and make new shaders on the fly, which led to, hey, now suddenly everyone can write their own shaders. That also meant that a bunch of other things. So shader generally means a program that's written for the GPU. Now there's a lot of programs nowadays that are written for the GPU that are general use programs. There's a thing called CUDA, which is essentially, NVIDIA wanted it so you could just write C++ and send it off to the GPU to do fast math, because that's what the GPU does. So for all intents and purposes, if it has anything to do with rendering, it's a shader. If not, it's just a general purpose graphics program, I guess, or GPU program. So that includes vertex, geometry, compute, and ray tracing shaders, I suppose, as well, which is relatively new. We're not going to talk about that because I'm not made of money. I can't afford those cards. So, like I just said, it's a butchered term. It's kind of been used to describe a lot of things that I don't think it should be. For one thing, in Destiny and in other fighting games, I guess, they'll use the term shader for essentially color palette or color swap palettes. And most of the high quality games you see where you're like, wow, what amazing shaders, it's actually just texture work. Like, most of the really nice, pretty looking games out there are 90% good texture work. The shader enables them to get that kind of really nice texture work, but most of the time, once the shader is written, it's just a matter of plugging in like your really, really nice wood or your really, really nice metal textures. So, what I'm going to teach. So, a lot of the hard skills from these workshops are actually just going to be outdated in 2 years. Unity is currently in a weird spot where they're updating a lot of their rendering pipeline stuff, such as I don't know if any of you have messed around with the scriptable render pipeline stuff. Anyone? No? Okay. So essentially they took their rendering pipeline, how they render stuff, and said fuck it, and they tossed it. And they're replacing it with two separate new ones called the lightweight and the high definition render pipelines, which kind of do things very differently. However, a lot of the lessons I'm going to be teaching you are going to be applicable there. It just means that some of the magic keywords and some of the weird Unity-isms are no longer going to apply. I actually think that the render pipeline stuff is good because if we get to that, and if I can teach that, your arsenal for graphic effects so much wider. It's kind of awesome. Also, I know shader graph exists. It's bundled with the lightweight and high definition render pipeline. I don't want to use shader graph, particularly because I spent 9 months learning how to do this the code way. And also, it's kind of got some weird issues. I think it makes it really easy to make mistakes, which I'll talk about a little bit later. And on top of that, knock at the door. On top of that, it's just generally kind of trapped behind the SRP, which again, I don't really love the scriptable render. I'm of two minds on the scriptable rendering pipeline. For all intents and purposes, we won't be using it here. So specifically what the plan is, so teaching you vertex and fragment shaders, surface shaders, some stuff that's immediately useful with that stuff, specifically like the sprite stuff, and probably some PBR theory, just some very, very light PBR theory. I'm not going to get into the math of how to calculate normals. That's way, like, I did this workshop like 2 years ago, and I stopped at normals because at the time I didn't understand it. I understand it now, but it's a little bit much. Stuff I might get around to: compute shaders, command buffer stuff, and some of the stuff that's outside of TechArt / related. Stuff like going through Substance Painter a little bit, going through Substance Designer a little bit, stuff for generating really nice textures and how to get that stuff working. So I'll also be sharing these resources I find and use. We've got Catlight Coding, oh my gosh, please do Cat-like coding shader tutorials. He literally has you step-by-step remake the standard shader. He is awesome, and he's written, so you're taking it at your pace instead of watching a video. I think that's super important. I personally hate learning code from videos because I always get either too fast or too slow. Lyndon Reed, Blizzard friends, say hi if you see him. He is at Blizzard currently. He came in and gave a shader talk to my capstone. I had used his shader for a class project once, and I walked up during Global Game Jam and I'm like, hi, I used your shader. And he was like, oh, thank you. He's super chill, super nice. Alan Zacconi, another one of those shader people. I don't know where he is. I assume Europe of some kind, as if there's multiple Europes. He put out a lot of good stuff. I think he literally wrote a book called Shaders in Unity 5.6, which is essentially the same system we're using for all intents and purposes. And Shaders Lab, which isn't updated as regularly as it was when I was learning shaders, but Shaders Lab is really good for like, hey, I need this kind of shader. How did you do it? And he usually has some variant of what you're looking for. So let's begin. At the start, in Unity, in not this scene. Oh my gosh, is the mouse not? Oh my god, why the mouse? Oh, there we go. Also, this Unity project is available on GitHub. I'll post that link a little bit later. Come on, go down. What are you doing? All right, so here is a scene, and I'm gonna maximize this on play. So this scene is to show you a couple things. So what do you see here? Anyone want to take a gander and say what they see? Yes, spheres. But what can you tell me specifically about the spheres? All right. So what color are the spheres? I know there's a lot of white and black dots on this monitor that are very abstract and stop you, but there's lights. So in this scene, I have two lights that rotate. Scene view, scene view. I have two lights that rotate. I have light 1 and light 2, and they're both point lights. And let's turn on shadows as well. So now, oh, lighting's not on. Yeah, there we go. I was wondering why that was weird. There should be shadows now, unless that's on receive no shadows. Sorry about this. Cast shadows, receive shadows. All right, I don't know why there's not shadows, but whatever, it doesn't matter. So we've got two lights and we've got rotating. And we've got 3 spheres. So each one of these spheres has a different shader attached to them. So this one all the way on the left has the most door, by the way, I think. This one on the left has what's called the unlit shader. So this is Unity's like super box standard like baseline. What's in the middle is the surface shader, and then what's on the right is the standard shader. So, you know, we're cool. We're awesome. So let's just see what the standard shader looks like in code. I'm sure it's not that bad. You know, I'm totally not doing this because it's terrible and awful and painful to look at. There we go. How many lines is this? That's not as bad as I thought, actually. Oh, wait, that's what? Parse combination. That's not what I wanted. Let me see this. Show. Oh, 55 variants. That's a variant thing. Hold on. Can it let me compile and show code? Let me see. Okay, there we go. That's more like it. So this is the standard shader. There we go. Shaders don't look like that. You are not writing a shader that looks like that. Also, this is compiled. So a lot of these are compiled for different kind of consoles. Like I think this one is, God, what is this? I don't know what that is. Blah, blah, for DirectX. So that'd be for like DirectX. So if you're on like an Xbox or you're on, I don't know, any Windows device, you'd be using that version. But essentially, most shaders don't look like this, and the shaders you will be working on don't have you do assembly. That's whack. If you're writing your shaders in assembly, I'm sorry, but you're like, you need to chill out. Also, you're a god, but you need to chill. So we're going to look at what is more common in shader code, which is the one on the left and the one in the middle. So the one on the left, like I said, is the most bog standard of shader code. And, you know, this doesn't look bad. But it doesn't do a lot. while the one on the middle does a lot more, and it also doesn't look too bad. So here's kind of the first note about Unity's shader systems. Unity will give you, if you right-click and go down to Create Shader, you get a couple different kind of shader types, but the top two are the ones we want to care about right now. We get Standard Surface Shader and Unlit Shader. Standard Surface Shader essentially handles lighting for you. All of the lighting, all of the reflection probe stuff, all of the, hey, metallic, smoothness, emission, it essentially gives you an easy way to immediately patch into Unity's graphics render pipeline. And that's really handy. If you're doing a game, sorry, I'm going to take a sip. If you're doing a game that is pretty much either A, photorealistic, or B, does have lighting in it, the standard shader will more often than not serve you fine. There are a couple exceptions to this, and I'll be very specific about why they're exceptions, but for the most part, standard surface shader is actually quite good and easy to use. And then there's the unlit shader. This one is literally, it gives you nothing. It gives you just, hey, it's on the screen. And then you have to go from there. I learned shaders by essentially recreating the surface shader inside of Unity via unlit shaders. I'm not saying that like I'm a G or anything, but like that was painful. I would never wish that upon my worst enemy to do. But also I was following from a cat-like coding tutorial. Go check them out. And we're actually going to essentially start with these two. So the first example I can say about surface shader is like, hey, look, it gives me lighting. It already has the lighting attached to it. I don't need to rewrite lighting to use the surface shader. And it's just kind of nice. It just auto does it. It looks really, really, really similar. There's very little differences versus the unlit shader. Now, this might look like a circle because it is a sphere, trust me. It does have a wireframe that is a sphere, and it is actually rotating. But because there's no lighting and there's no shadow, the entire three-dimensional aspect of this object is lost. It might as well as be 2D. So that's kind of the stuff we're missing when we do a vertex shader, or sorry, unlit shader, and this is the kind of stuff we get from surface shaders.
Do all of them have the same texture?
None of them are textured. I'm sorry, I've been
Or
input.
the colors?
The colors are coming from the light source. So I have 2 lights here, 2 spinning directional lights. Also, general advice, don't have 2 directional lights in your scene unless you're trying to make something look pretty like a photo shoot. Otherwise, don't do it. So I've been talking a lot, and it's been pretty unstructured, I'll say. Does anyone have any questions about anything I just said? Okay, someone has to have a question, otherwise I can't continue. I'm like that NPC that just bugs you in this game. Seriously? I just told you guys I'm not going to do anything more until you ask a question. Okay, it doesn't have to be about shaders. You can ask a question about why this TV is so shitty. It's dying.
Why is the TV so shitty?
It's dying. Cool, now we can continue. So,
I was gonna ask what makes the standard shader different from the surface shader.
so we're gonna call this the unlit shader for now. Yeah, I should say. The thing is that the surface shader, and once we get into the code bits, I'll point out exactly what I'm talking about. But the surface shader essentially has a lot of includes and header files that redirect to how Unity does the standard surface shader, or the standard shader in general. So it's essentially pulling information from the surface shader in general in order to recreate that, but with a little bit more flexibility. Whereas the unlit shader here does none of that. It does not help you at all.
Oh wait, no, I think I was missing the thing. Again, between the middle one and the right one.
Oh, the middle and the right one. Okay, so the first thing is that if I pop this is what the surface shader gives you by default,
Yeah.
and this is what the Unity standard shader gives you by default. There's a lot more there. And there's a lot of extra stuff that Unity is probably doing in the background with their standard standard shader. It's going to get really annoying really fast. That essentially has helpful optimization techniques at the expense of flexibility. Where the middle one, you have flexibility in code to change stuff. For all intents and purposes, they're using the same lighting structure, and for the most part, they're very, very similar code-wise. But once you get down into the guts, you have a lot more flexibility with the surface shader than you do the standard, because you can actually alter it. You can't change the standard shader; it's locked in. But let's just look at the code for one of these. So this is the code for the left one. Can you see in the back? Also, I'm gonna post this to GitHub. Everyone can see? So this doesn't look too terrible. It's about 60 lines of code, and 60 lines of code to get a white sphere to render is not terrible. Heck, it even says, "Hey, main text." We'll get to that. But can anyone point out anything like immediately weird about this code? Because there's actually quite a bit that's very strange. Giant shrug. No weirdness. Everything looks normal. You could have written this already. You didn't need me here.
They kind of look like they're all struts, or rather than classes.
Yeah. So Unity shader system isn't quite the standard shader system from like a DirectX or an OpenGL. It's built helpers. You are essentially working within its framework, and that's a good thing. Trust me, that's a good thing. So let's just like take this line by line. So the first thing we say is, hey, guess what? This .shader file, yeah, it's a shader. Good. But what's all this then? So tutorial 1, left. So this is not immediately apparent, but this is essentially the name for the file. And if we go down here, you'll see that, well, it's very small, so let me just do this. Unlit, oh, sorry, where's tutorial? Tutorial here. Tutorial 1, left. So essentially, this is where we're putting the shader in a file structure. I don't know where this file structure necessarily is. It's abstracted from Unity, or from you by Unity, but it's there. Now, properties. So anyone want to take a crack at what properties is? So been trying to ask people questions. I feel like I'm moving too fast.
Let's see if you can assign at inspector.
Exactly. Yeah.
Why would you need to declare properties compared to like traditional programming where you maybe have a class and have a member for your class?
So first of all, this gives you essentially access to the inspector, and it puts it up in the inspector like a public variable. But also, again, this is kind of writing inside of Unity's system. So my assumption on the back end is when you do write properties there, it's actually got like a separate script inside of it that's essentially declaring, hey, public texture. This is a texture. And it pops it into the Unity editor. And that essentially also opens up buffers to talk to the GPU. Like I said, there's a reason why this is nice. It used to be that if you wanted to pass anything to the GPU, I could actually probably do that. I'll do that another time. You would essentially have to go and write a script that would say like, hey, populate GPU, I'm telling you set this variable to that in a separate script entirely. Which is annoying. It's pretty abstract and opaque. It's especially opaque when it's like you have a script and it's like shader.setFloat horizon equal 1. And it's just like, what was that? What is horizon? And it's like in a completely different place because it's in the shader. So with properties, we just kind of are allowed to say, hey, write it here. There, done. It's very nice. I would rather write Unity shaders than DirectX or OpenGL shaders any day of the week. Primarily because I don't know how. So we can declare properties here, and that's really helpful. So let's just say underscore, I don't know, color. And then we can say color. And if I flip back over to Unity, well, it should have a compiler error probably, because I assume that that's just not done. Reference unknown behavior. What do you mean unknown? Ah, fuck off. So that should probably, yeah, get used to seeing that color.
Yeah.
I refer to it as shader magenta, shader pink. It's essentially the most uncomfortable, unnatural color you can see. And there's a reason. It's so that you'll notice it, so you can fix it. I've talked to a Blizzard engineer, and it was fun because I was like, what shader error do you guys have? And he's like, oh, it just defaults to the last properly compiled one, which means that if an error occurs, they can't visually see it. If you've played old source games and you've had that black and magenta color pattern, that's a shader error. Something went wrong while it was trying to render stuff, and it said, hey, this is the ugliest thing we can put in front of you to tell you that something is wrong. Fix it. And I'm like, dude, I'm an end user. I'm 12. I don't know how to fix this shit. So it's kind of, it's not very worthwhile for your end user, but as a person who's writing the shader, it's super helpful. So let's go back to this and maybe fill it out. So,
Is there a reason for the underscore in front of it?
No, it's just,
Unity?
so it's,
Good practice.
it is good practice, but when you start writing surface shaders, it doesn't matter. This is one of those things where writing vertex shaders and surface shaders are kind of sometimes a different beast, where surface shaders really demand that you put an underscore in front of your variables. I do not know why they want to do that. It's probably for parsing, but hey, you know, I'd rather play nice than be annoying and be invisible. So let's just set this to 1111. And this should give us a color. And it compiled properly. And if we check down here, we have color in all caps. Let's change this to object tint. Come on, come on. Oh my god, did I just delete everything? Okay, cool, I didn't. Well, I did, but. So yeah, if, I don't know if those of you in the back can see, but I've essentially changed the wording here to object tint. Being able to change how your shader property is named inside of the editor is really handy, especially when you have to hand off this shader to a designer or another programmer. Being able to just give them a name that makes sense to them, super helpful. Because then, you know, you don't have to go and be like, color means color. It's like, they'll get it, color means color. However, if I change anything on this, nothing really happens. So we've declared color, but it doesn't do anything yet. And let's just go down this entire shader until I can add color and where to add color. So, subshader. Does anyone have any clue about what this could mean? This is very particular, but
I guess you're saying confused why the word subshading. I mean, there's multiple.
you want to use subshader when you're going to have like multiple different variants of the shader for specifically different for different hardware profiles. So if you want this shader to work on console and you also want it to work on mobile, you likely have to make hard adjustments for that. So what you can do is write a subshader that essentially automatically chooses which one to use. At which point it's like, cool, I don't have to write like 15 different shaders for 3 different consoles. I just use one subshader or 3 subshaders per file, which is nice. Tags are annoying. I'll get around to that. That's when Unity's auto magic system gets very annoying.
What are the 2D and color things? The variables.
So 2D means that it's going to be a 2D texture. This is a texture, by the way. I wish I.
The type of input.
Yeah, it's the.
Allowing it to be.
Yeah, it's the type of input. So I just had that texture lying around. So 2D generally means that it's a texture. There's other kinds of inputs, and I'll go over those later. Range, cube maps. Gosh, what else is there? Vectors. You can just pass it a vector. Floats, individual floats. They're handy. And also all of this is accessible from scripts, which is also really nice. So if you wanted to say like, hey, change the texture, change the color on my object, you could from a script. Even from an animation, which is super nice. I've never done that before, but being able to make animation curves that change your shader, perfect.
What's the name of this language?
Okay, so this language is called CG. And I'm going to show you something that I hope doesn't make you leave immediately. NVIDIA CG. So this was a programming language that was made by NVIDIA. And CG is a legacy NVIDIA toolkit no longer under active development or support. CG was a choice that Unity made a long time ago, and they never left. Even NVIDIA tells you, don't use it anymore. However, in terms of actual usability, it's quite nice. It's fine. In terms of graphics programming languages, you know, they're all pretty much the same. There's about 3 of them, including this one, so there's actually 2. It's essentially a clone of Microsoft's shader language called HLSL, or High Level Shader Language. Godot, if you've ever written shaders in Godot, uses GLSL, or Graphics Library Shader Language, I think. They're very, very, very similar. Some words might be different. I know in GLSL they don't have lerp, they have mix. But, you know, if you can do it in HLSL, high chance you can do it in CG, high chance you can do it in GLSL. So, short story short, you're writing in CG, just call it HLSL. It'll look better on your resume. Trust me. No one is looking for, like, look, oh gosh, I got confused because of the stream. Going forward, we recommend new development with GLSL or HLSL for Windows applications rather than CG. Fun times, great times. But it's in Unity, we use Unity, so we'll stick with it. Thanks, NVIDIA. LOD, so LOD stands for level of detail. When you have really high quality textures, you generally are like, when you're super up close, you're like, yeah, I want to see all that detail. But the farther out you get, the less detail you see. At which point it's like, well, why am I rendering this like 4K texture if it's like 2 pixels on the screen? So level of detail essentially lets us turn down the level of detail on a texture at runtime. So it's not loading in and rendering this 4K texture when it really only needs to do like 2 pixels of it.
What does the subshader part of program?
Subshader? Oh, subshader is, it essentially lets you write the same shader multiple times for different hardware profiles. So if I wanted to write a shader for a console and a PC, or sorry, and a smartphone more likely, there are certain things that in the shader, it's like, well, this is stupid, that's never going to work on mobile. But instead of essentially making 15 million versions of that shader, you just add a subshader and Unity will automatically say like, hey, use that. It's essentially good for keeping your code portable and clean. I've never had to write more than one shader. I work on PC, primarily. Fuck them all. Pass. So, hard pass on this. Who wants to explain it? Okay. Well, I guess not hard pass on that. Pass essentially means draw. It's equivalent to calling draw. One pass, one render pass. Just go over it once. There are some times where you're going to want to go over it multiple times, multi-pass rendering. I would highly suggest against doing that unless you're gunning for an effect that you really can't do without it. You know, one render pass isn't going to kill you, but 2 render passes aren't going to kill you either. But if you have an object that you have like 15 render passes on and you instantiate that like 100 times, you're now doing 1500 draw calls, which is kind of whack. You shouldn't do that. You'd be surprised how fast things catch up to you. So try to keep it to 1 pass, but if you need multiple passes, that's fine. Just make sure you're not crazy.
What is the tag?
The tags are a Unity magic thing. I really don't like them, but it's essentially things to tell Unity how to treat your shader. So like if your shader is going to be transparent, it needs to be rendered after everything else. Because how can you, like, I guess the best way to put it is like, gosh, how do I put this? With transparent objects, you really want to make sure that the thing behind the transparent object is rendered first. Because if you're trying to render the thing behind the transparent object second, you're essentially rendering on top of the transparent object. At which point you might as well just not have the transparent object. So essentially, there are things like the tag system where it's just like, hey, render type transparent or render type opaque, lighting mode, forward add, lighting mode, forward or deferred. And I'll get into those later. Personally, it's my least favorite part of writing shaders in Unity because it's a lot of me going to Google and being like, Unity shader tags, what it do, subshader tags, and it's just like rendering order and the queue and batching, and it's just like, this is annoying. I don't like dealing with it, but it's there. It's there to hopefully go away soon, which would be nice. So, any other questions about the first 13 lines of this code? I know I'm kind of blasting through this, sorry to say, and a lot of this is just going to be straight up like, the rest of today is going to probably be a lot of blasting, and then I'm going to try and get to something fun and explain something. But there's a lot of nonsense in here that I just feel like needs explaining. So, any other questions so far? No? Okay, cool. So CG program. This is essentially declaring, hey, we're writing in CG. Now you can actually do HLSL program, like that works. Unity has support for it. I've never seen anyone do this, but it works. So if you want to use a not deprecated graphics language that's essentially the exact same thing as the graphics language you're already using, go ahead. I don't see any reason why not to. All right, Pragma. So this is going to be a hard CS thing. Not difficult hard, but like it's a known thing. How many of you have taken C++? The C++ classes here. So you remember how, I assume you all had Thornton or Clefstat, correct? Anyone have anyone different?
Goggle for 46.
Gaga for 46, okay. So you remember when you're writing a header file that you say pound sign, I'm not going to call it a hashtag, pound sign, if and def, that thing. So that's what's called a preprocessor. Essentially, when you're writing code that compiles, you can give the compiler stuff ahead of time. Like, you know, if you were writing a library and it needed to work on both Windows and Linux, because, you know, Linux. I legitimately like Linux, I'm just bashing. But essentially, there are libraries that you need to rely on that don't exist in Windows, and there's libraries that don't exist in Linux. And if you try to compile it, even if you're like, if Linux, else Windows, the compiler will yell at you, because it's like, yo, what the fuck does Windows input mean? What the fuck does Linux input mean? Like, on a Windows machine, it'll say, what the fuck is this Linux shit? And on Linux, it'll say, what the fuck is this Windows shit? So what you can do is you can tell the compiler ahead of time, hey, this is a Windows machine. If we're compiling on a Windows machine, do this code. If we're compiling on a Linux machine, do this code. So essentially, when you hit compile, it's not going to ask questions because it already knows to discount the other part. It's essentially forward checking. It's making sure that this stuff is not going to give you a problem by being very explicit about it. Now, that's essentially what this is. Long story short. Pragma vertex vert is essentially saying, hey, compiler, there is a vertex function. Guess what? It's down here. It's called vert. And the vertex function is called vert. And hey, ahead of time, there's a fragment function. It's called frag. It's all the way down here. Frag. It's essentially just telling it ahead of time, like, hey, this is what you have to look for. This is what we're going to give you. This is what we're going to do. Pragma multi-compile fog. Fuck it, I don't care. It makes the fog work inside of Unity. I mean, that's what it do. Nothing really to that. All right, include CG Unity CG includes. Mayan, what are you doing? You can't. I tried myself.
Fine, you have the whiteboard.
Trying to hide from me. That shader's transparent. I can see through it. All right, include Unity CG.CG include. So this is essentially an include file. It's a bunch of helper functions. If you're writing a shader, you should probably have that in there. A lot of the Unity-specific functionality is in there. Gosh, do I have that file somewhere? It's somewhere deep within your Unity files. I don't know off the top of my head where it is, but if you really want it, you can find it. All right, so now we're actually writing a shader. All of that was just Unity-isms. I'm so sorry. But now we're actually writing a shader. So the first thing is struct app data. Does anyone have any idea what this could be? I mean, let's look at the info we have here. Vertex. Does anyone have any inclination as to what a vertex might be in this context? I'm call on someone if no one answers. Call on someone that I know specifically does not have the answer. So, app data in this context, it's the model we're giving the shader to. So essentially, this is getting information directly from the model. And again, this is one of those auto magic things, really dislike it, but it is the info from the model. So in this case, float for vertex is every individual vertex on the model. I should probably show this. Most 3D models are actually just a bunch of points in space with lines connecting them. Each one of these points is called a vertex, or a vertex. And this is essentially saying like, hey, here's a vertex, here's a point in space. UV? Dude, I don't fucking know. I have looked into UVs like multiple times. Mayan, stop. I have looked into UV, the definition for UV, multiple times. The Wikipedia page has 2 different definitions as to why it's called UV, and I've literally gotten into a fight with someone about this. Where one definition is, it's just arbitrary points. They chose U and V because they were out of X, Y, and Z. And the other one is cross-product related, where if anyone's done cross-product before, you have 2 vectors. One is called V and one is called U. This is related to texture. This is essentially where does the texture map onto the model. If you have a texture, you need a UV. You can create UVs inside of Maya. It's annoying. I have to do that later today, but it exists. So yeah. So that's all the information we're getting from the model. Like, that's it.
How does it know? Like, what is this position?
So
App data a keyword?
So honestly, no, it's not. Or it might be. I know that there's different. Let me double check this. Oh, Unity app data full. So the nice thing is that Unity has manually providing stuff, CG, past, blah, 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 semantics specified for it. I am not sure off the top of my head why it's called app data, speaking honestly. Application data. And I know that Unity has pre-made versions of app data that have different info in them. So instead of having to define this struct, you just say, hey, app data full, which gives you a lot of extra stuff. So the nice thing about app data is that you can get a lot from the 3D model. If you've done 3D modeling before, then you, gosh, it's kind of specific, but you can essentially take a vertex and give it a color, like very specifically. This vertex is red. It won't show up on your model because it's not a texture. But if we wanted to do something where we said, hey, you know, vertices that are red fluctuate, or vertices that are red fly up into the sky and stretch our model out really poorly, we can do that. And there's a lot of interesting use cases for those. One thing I saw was that a painted vertex, which you can actually paint vertices in Unity using some plugins. A painted vertex in Unity turns the model white at that point and then pulls the vertex down, which makes it look like it's covered by like snow or ice. So you can get some interesting effects out of color. You can also get normals, which we'll talk about later. Normals are fun. But yeah, so that's just a very simple struct app data. And now struct v2f. Does anyone want to hazard a guess of what v2f stands for?
Vertex to face.
Very, very, very close. It's vertex to fragment, which for all intents and purposes might as well be vertex to face. And it's essentially, if you look at it, kind of a carbon copy of the app data. You know, we've got UV and text coordinate 0. That stands for texture coordinate. I literally went 6 months not knowing what the hell text coord 0 was. It stands for texture coordinate. Because we only have a limited amount of text coords actually. So if I like do like text coord, like see we got like up to text coord 19. I don't know why you would ever need a text coord 19, but you might. And then again, here is vertex, except this vertex is actually different. This vertex is the translated vertex from world to the camera. And once I show you the next function, I'll be able to explain that better. Also, here is where the properties thing kind of is weird. You have to redefine your stuff with the same name as the stuff in properties. So essentially, you need to say main text again as you did up here. This is because the old way of doing shaders was saying, hey, declare a function or declare a variable inside of the shader, and then outside of the shader in the script, pass it the string to search for in the shader, and be like, hey, change that thing. That's really wacky. I don't like that, but that's kind of a remnant of why you have to redefine your variables. And a sampler 2D is essentially texture. It's just a texture. Float 4. So this is actually not the first case of one of my favorite actual things about shader languages. No vector 3. Don't have to write out vector 3. You just get to write float or int or fixed, whatever number of those you want, and treat it as a tuple. It's just a tuple. And it's a really nice tuple too, because you could do like float for whatever, that's not how you spell whatever, is equal to 1, 1, 1, 1, or let's do 1, 2, 3, 4. 1, 2, 3, 4. And I can do whatever dot x, and it gets me 1. Dot z gets me 3. Y gets me 2. W. Yeah, I know, right? X, Y, Z, W. Fun. This also works for RGBA. Essentially, it's just things about shader languages, and it's actually kind of being added into Unity in general. Personally, I hate vector 3s. They're just cumbersome to use. I know that sounds bizarre, but I'm a particular person. All right. So we're passing in the, what are we passing in into this function? What struct are we passing in? So we're passing in, what does app data represent? Yep. So we're passing in the model into this vert function, which is the vertex function. So we're saying, all right, hey, we're gonna initialize a v2f, a vertex to struct, or sorry, vertex to frag struct, and then we're gonna do some stuff. So this is where, how many of you have taken 6N linear algebra? You don't need it that much here, but it will help your understanding. We're essentially saying o.vertex, which is the o.vertex inside of our fragment, or vertex to fragment, unity object to clip position. Hoo boy. Okay, and then we're passing it the object vertex. So unity object to clip position is a very particular function, but it's not magic. I actually know how this one works. Essentially, when we're in a 3D space, we're dealing with a lot of matrices. Sorry to say, matrix math will never leave you if you follow this. And every 3D object has, every vertex in a 3D object has a transform. So like, you know, if I have a sphere, there's a vertex that has 1, 1, 1. 1x, 1y, 1 on the z. However, is that relative to the world, or is that relative to other vertices in the object? So essentially, we can say like, hey, you know, this vertex is 1, 1, 1 inside of the object, but it's not 1, 1, 1 inside of the world. It's a very fine distinction, and you essentially have to do some matrix multiplication in order to escape object space into world space. And then you have to go from object space to world space to view space to what's called clip space. So clip space is the thing that gives it the fake 3D. If you've ever looked at a picture of a train track, you know from a fact that those train track like treads, like the rails, never touch each other. They're perfectly parallel. However, if you look at a picture, you'll notice that as they go farther and farther in, they kind of look like they're starting to meet. Realistically, they never do, I hope. That train's in trouble. But essentially, the last transformation, clip position, is inserting that fake sense of depth. That, hey, as we get farther and farther away, things get smaller and smaller and smaller. So I'm going to show you what happens if I don't do this. Yeah. So that looks weird, but it gets even weirder. It just, you know, decides that it's going to not play nice. It's always going to follow me. I cannot escape this cursed sphere. So we're gonna force it into place. There, you're in place now. And there's other things we can do. We can do Unity object to world position, I think. World position is a thing. World direction, whatever. There are older Unity documentations that do mul, which is multiply, and a function that is essentially the vertex and then some very set matrix. Fun fact, if you do that now, Unity will actually go into your script and change it for you, and then leave a nice little comment that says, note, changed this to this. I think that's hilarious, but also as someone who is trying to mess around with that stuff, hyper infuriating. So Unity object to clip position. We're setting it in the world, we're setting it to the camera. It's gonna be weird and distorted, because we have transform text. So this is essentially taking the texture we have and saying, hey, bind it to these UVs. Slap it on top of this UV map. This is how it's gonna work. Speaking honestly, UV stuff is the stuff I'm the least qualified to talk about, but I don't think anyone else in the world is either, except for maybe like John Carmack or like some other graphics programmer god. All right, so we're finally at the last part of this shader. I'm out of breath. I need more coffee, and I wish I was getting paid for this. But if I couldn't pay my officers, Riley can't pay me. So the first thing we're gonna notice here is that fixed for. Fixed for is the return. You know, it's obviously the return type of the function. If you've taken a C-based programming language, what is a fixed for? A fixed for is weird. Essentially, it's whatever Unity needs it to be at that moment. So on computers, specifically PCs and consoles, we're very used to using floats. Floats are, I believe, 32-bit, 4 byte. They're very, very precise. However, if we were to jump onto, say, a mobile processor, like an iPhone or an Android, they're not going to be as precise. They are going to have maybe even half of that. So what they have is called a half. It's literally called a half. Half for, literally there. So what fixed is fixed will essentially adjust its self-definition to whatever machine you're using it on. And then what we're, not a 0, 0. And then what we're saying is fixed for, return type, it's going to be our result, col, just the name, is equal to text2d main text i.uv.
What's
Color.
Oh.
Yeah. Essentially, this is the function that slaps the texture onto the model. We are finally done. We return the color. We end CG. You have to put that there to say, hey, it's the end of the graphics program. And we're fucking done. Sick, we got something on screen. Holy shit, that's a lot of steps and very annoying. But trust me, once you get very used to this, it kind of just becomes second nature. And hey, now that we know what's going on, we can even add our color. So let's, just do a straight up multiplication, and maybe it'll.
Do you have to?
Does anyone know exactly what I did wrong here?
You need to redefine color. Yeah.
Exactly. So, literally in this bizarro space between functions, we would say float underscore color. It's not a semicolon. There. That's intended. Trust me, it is. I think. Wait, why is it black? That's why. Oh, right. Yeah, my bad.
And you can just multiply float first.
Yeah. So, yay! We can change the color. Woo! So you'll notice that we're getting specific color changes where the object is white. Basic multiplication. What happens when you multiply anything by 1? Exactly. So if we have red, yellow, green, any RGB value times white will be itself. You'll notice that everything that was weird and blue is kinda, depending on the color, we might get this weird green color, we might just get pure black, we might get that nice, oh god, that's shader magenta, get the hell out of here. We might get different colors for it. Essentially, a lot of it is going to be like, hey, I have these four values and these other 4 values. What do I get when I multiply it? And that's okay. That's fine. It's really not that bad. You can also add color if you want to. I generally don't know or think that's a good idea. because you'll end up essentially overwriting whatever your texture is unless you're very specific about it. Like, see, that's just pure white now. And I could probably give it any color and it'd just be like, what the hell are you doing? Like, why are you doing this? Like, only in certain situations does it work. So, essentially what happens is if we go over 1 in the color, it's just going to go to white. Now, in the background, it is defined as not quite 1. It's probably over 1. And that could cause problems in later calculations down the line when you expect things to be 1. But, you know, just make sure you know that this should be 1, this should be 0. And with that, I have officially gone through the vertex shader, and I don't have any time left. Unless people are okay with staying just a little bit longer so I can show how much easier the other one is. I don't see any no's. So, okay. Cool. So now I'm going to show you what the other one is. So hey, look, this is familiar. That's the properties. And hey, look at that. What's this? Range? Excuse me? What is that? It's this nice little slider right here. And you'll notice that we're kind of going more and more smooth and metallic. If you ever mess with materials inside of Unity, this probably feels very familiar. And then, hey, you know, subshader, that's the same. CG program, that's the same. And what the hell is this? What is that? So the way that surface shaders inside of Unity work is it's essentially one big precompile. It's essentially saying like, hey, this is a surface shader. We're going to use surf. We're going to use the standard lighting model, and it's going to have shadows in it. And Unity has a lot of these. If I go to the Unity documentation, never use the built-in search function in Unity's docs. It's very whack and not good. Yeah, so we got lighting model, standard specular, Lambert, all of these optional parameters, alpha blending, vertex function, all this other shit. This is what I kind of mean by surface shader is really good if you're trying to do things that have to work normal, like, oh, it needs a shadow and it needs, you know, lighting. But ripping those out of the surface shader is hard. It's annoying, and frankly, it's kind of frustrating. I've had times where I want to do a shader effect, and I found it's actually easier for me to start from scratch with the unlit and go to that rather than work backwards from the surface and go less realistic. It can be annoying, but when you're doing primarily realistic looking things, this is a godsend. Pragma target 3, essentially saying, hey, give me the nicest looking lighting. Target 3, you know, that's a Unityism. Sorry, don't really have much for that. Hey, look, we're defining a main texture, and then we're saying input. Well, that's different. That's not quite app data, but you know, it's an input structure, and you know, I assume that's stuff we're going to give it in. Instancing buffer, that's something very particular. I'll have to explain that later, probably. And then, oh, there's no vertex function here. There's no other structs here. It's just this. This is why I like surface shaders. They essentially say, hey, we have a struct. It's called surface output standard. And we expect you to put all of your values into O. So the color, the metallic, the smoothness, the alpha. We even got emission, I think. O.emission is equal to float for, let's make it red. Let's make it glow red.
What is
In-out is essentially a way of doing referencing. It's like calling a direct reference to. Essentially, they pass it into this function, and then that values then go out. If you've ever done C++ programming, it's like being very explicit with your references. C# has in-out, I think, because C# kind of is weird. So now, what is that? Oh, right. You know, every once in a while, I forget a semicolon, because 5 years of programming haven't taught me that semicolons are important. So now look at that. It's bright. It's red. Big shiny red candy-like button. Anyone get that reference? I don't want to feel old. Please. Please no. But essentially, we're saying like, hey, make it emit red. This is why standard surface shaders surface shaders are really, really nice, because it just works. It just works. Yeah, I know, right? And that can be really, really good for some situations. Like for my capstone game, I wrote a lot of surface shaders because I said, hey, you know, I don't have time to rewrite the entirety of the standard shader, so let me just write a surface shader. And it's nice, and it's kind of easy to use. You know, you just set the colors you want to the struct outputs you want, and you're good. Now I'm going to show you something fun. So this repo is actually my personal repo that has other things on it. Don't save. So this is something that you can do with a, oh, why is it gross? Okay, everyone. This is a pet peeve of mine. I'm sorry, I'm going to bring it up. If your Unity looks blurry or anything, go into the aspect ratio and turn off low resolution aspect ratios. It locks you into being 1.25 times closer than you should be, and it will make things pixelated. I don't know why it defaults to this, but it just does. So here is an example of a shader I did, and I was very proud of it when it happened. So can anyone kind of explain what's happening? Like, what do you see? What's happening on screen right now? That's a good way to put it. So let's get a better look on this. Let's go to the scene and say, hey, let me click on you.
Why is it moving?
Maybe. So what's it doing? Like, why does it look like that? Why is it being weird? Why is it being annoying? So this is actually this is pretty much the unlit shader. I think I changed 2 lines in it. Okay, it's more than the unlit shader. It's got some lighting work in it, but because I essentially said like, hey, you remember how we had to go from object to world to view, right? So what if I didn't just jump directly ahead to view? Now I have the object in the world, and its vertices are at world points. And what if I said, you know, hey, you know that 0.0001 for that x? What if I just said no? What if there wasn't a 0.0001? What if I actually said that, hey, it only matters on the 1? What if I essentially set it to integers? So there's no little tiny bits floating, moving. That's what I did. I took the vertex, this is the output vertex, and then I took the input and set Unity object to world. So that's essentially saying like, hey, take your object space stuff, put it into the world space, which is super duper handy. And then I essentially said round it, meaning, hey, get rid of the float values. And I rounded it by some lock value, which essentially is me having bad terminology. This is actually kind of unintuitive. But essentially, it's me multiplying it by, say, 100. If I multiply a value by 100, round it, and then divide it back, what do I get? Well, I mean, probably it's the same value. But if I said, hey, multiply it by 1, divide it by it, and then round it, what do I get? 1. So then I just multiplied it to the view matrix, which essentially says, hey, now put it in the view. And what I get is this tiny little shader that lets me essentially say like, well, you know, all of that precision that Unity worked so hard for, fuck your spheres, fuck all that. It's a cube now. And it's only gonna run on the 1s. So you'll notice that like it's kind of moving sluggishly, bit by bit, tiny by tiny. And this works on the Y too. And we can choose how much precision. This is like, why is that a number I can do? Let's do 1. So now essentially everything is gonna be like locked to a 1. It might as well as just be an int. All of that nice stuff where Unity is like, hey, you know, let's move in very, very small amounts to make it look realistic. Fuck it, doesn't matter anymore. So this is actually done fairly efficiently. The one problem is that if I go into wireframe, it doesn't look too bad, but the reality, well, it's barely visible because of the TV. But the reality is I'm not actually cutting out the vertices. There's still as many vertices as there are. It's just that I'm essentially clamping them all to be like 1 or 2 spots. So that's something you can do with a shader.
Yeah. Shaded wireframe.
Shaded wireframe? Oh, is there shaded wireframe? Oh, there is. I didn't notice that before. Yeah, there we go. So as I decrease it, essentially I'm just saying like, hey, you know, snap it to an integer. Woo!
So interesting.
Yeah. This could be a fun effect in a game somewhere. I can't think of what it would be off the top of my head, but it can be there.
It's like those pixel shaders.
Yeah. So this is the different shader I did. It's not quite ready, but let's go shaded. Essentially, it's kind of trying to mimic a very particular look. Also, I think, do I still have it? Yeah! Yeah! That wackiness. Essentially, I wrote this shader because I was trying to mimic, gosh, what is the name? Mobius, comics? Images. I was trying to mimic, oh, gosh, I'm not going to be able to.
Chowder.
No, not the effect from Chowder. Gosh, I'm never going to find it, but the way that this person, oh, it's probably Jack Kirby. So the way that like old comics used to do galaxies and universes is that they would essentially have like just a hard color, and then they'd have a bunch of dots on the periphery, which kind of made it this cool, nice look. Spider-Verse actually kind of mimicked this look. They explicitly call out Jack Kirby's dot style, and I tried to mimic it. It didn't work, but you know, it's just one of those nice, cool things that you can do, and you know, you get the ability to mess because you can do vertex shading. Oh, sorry, hold on. Galaxy, open that up. So in the vertex program, I literally, oh gosh, that's frustrating. But like, just take it from me. I essentially just multiplied the vertex. See it? I essentially just multiplied the vertex by some amount in order to get that to work right. So that's pretty much all I have for today. I info dumped a lot, and trust me, I'm super duper duper sorry about that. I am going to actually make something that is fun for you next week. Wish I had a preview for it, but you'll just have to believe me when I say I already coded it. Don't believe me when I say that. But I'll figure it out. Does anyone have any questions? Because you should.
Sample 2D, but why is it called sample?
My assumption is that it's sampling a 2D image because essentially at runtime it can transform that image. There's a thing called sampler 2D LOD, or level of detail, where you can essentially say like, hey, blur it. Like get it blurry. So my assumption is that it's because their thought process is it's sampling from a 2D texture.
You apply a shader to an object.
Oh, I never went over that. I'll do that really quick. Essentially, when you want to apply a shader to an object, you have to make a material first. And then you apply the shader to the material. So if you click here on the thing that says shader, you have all of these options. And usually when you make a new shader, it'll probably be in unlit or in surface, FX, flare, particles, all this other stuff. And that's based on your name stuff again. So the name up here is Unlit Galaxy, shader Unlit Galaxy. So if I change that to stupid, I don't know. And then went to here, stupid Galaxy. So yeah, that's how you apply a shader. Very helpful, I suppose. You know, it'd be good to know how to do the stuff I just taught you. That'd be really nice if you could actually use it. Sorry about that.
From the script side, how do you make a shader that changes color over time?
Oh, so there's kind of a couple different ways to do that. Let's just grab this one already.
Or allow a script to change the color of the shader, even though you can.
Oh, okay. So that, let's make a new script. New script, color changer. See you later. Color changer.
I know you can access material, right?
Yeah, you can access the material directly. So let's just do like private material. Oh gosh, there's no IntelliSense. All right, I'm flying blind here. I'm sorry, Matt. And then on void awake, we want to say Matt is equal to get game. Oh my gosh. Dot get component. Gosh, I guess it would be mesh. Dot material. That's probably not right. That's definitely gonna throw a compiler error, but you know, live and learn. What do you mean doesn't have get component?
Capital G.
Oh, capital G.
Oh, right. Gosh dang it. Mesh does not contain any, hold on. That's not the data type for mesh. Why don't you just give me the, oh, cool, that's actually helpful. Mesh filter dot mesh. I think maybe dot met. Hold on, mesh. I swear.
Unity has a different
Yeah. Let's just. Render dot. I was right. It's just renderer, not. Renderer. Okay, cool. You gonna throw an error at me? Mesh does not contain. Okay, that's not right, but cool. All right. So then what we want to do is mat.set. Would be set vector. Oh wait, I can just. Did you say we're flying off the rails? I mean, we are though. Set float, set color array. So let's just say mat.set color array. What was the input for that? Oh gosh, list of color values. Why don't you just give me a? Why do you do this to me? Is set color there?
Yeah.
I missed it. I'm sorry. Oh, color dot value. Cool. So I can just be like red, black, blue. So this is gonna lose the ability to be. It's probably gotta be color dot black, right? Excuse the shoddy everything. Takes one argument. Set color string. Oh, right. So you also need to pass it the name of the value you're trying to change. Yeah. Yeah, it's a little weird. This is that old school stuff that you have to do. So that on play should just set it to black. Or not, you know, that'd be fun. It's also not rotating.
Can you attach the script? Right?
Is this script attached? Yeah, script attached. Let's just do the thing of. Yeah, that's the American.
Maybe it's a smaller case.
Well, it's waiting to play. Material.set color.
Yeah.
Color.
I mean,
Black.
I mean the string.
Oh, the string.
Yes.
Select shader. Yeah, it's lowercase. Hey, it actually worked for a second there. All right, yeah.
I didn't know you could do that real time.
Oh yeah, so it's fun because shaders actually compile at runtime. If you change a shader while the game is playing, it will actually change it, recompile it, and just go. So it means that I can just leave this in play mode and be like, you know,
Change it to red.
yeah, I could just be like, you know, hey, you know, why do I care? It just works.
Does that mean I can read this file as a text file in runtime and send it?
I mean, I guess so, if you want to. But yeah, so, and also there's a lot of extra stuff, so.
So it's just not like a dictionary of all the variables.
It's probably not a dictionary. I don't know how it is, speaking honestly. It might be, yeah, it might be a dictionary, and then that dictionary probably has a value that points to something. Long story short is that a lot of the niceties you get out of modern programming and programming languages and programming on the CPU, you kind of gotta toss it once you get on the GPU. The number one thing is, don't do if statements. Just don't do them. The GPU is built for pipeline. It's built to take everything step by step by step by step. However, if you introduce branching into the pipeline, what it does is, well, we can't deal with branching. So what it does is, it does both. You've literally cut your efficiency in half, because it will do both the thing that is false and do the thing that is true. And then once it hits the end of runtime, it'll say, well, which one was it? And then it'll do the right one. So, and also you don't get a lot of data structures. If you like linked lists, sorry, don't exist. Arrays exist though, enjoy those. And you also don't get very large arrays. Good news is that for loops are okay. I learned that recently. The condition inside of a for loop, this is a little bit higher level. The condition inside of a for loop can be determined at runtime, or sorry, at compile. So if I say like, hey, I need this to loop 8 times, and say specifically 8 times, then what the compiler will do, it'll say like, well, we don't need a conditional. We know this is going to run 8 times. So at compile, it just writes it out 8 times. Yeah. So for loops are okay. I would suggest against doing them as well, unless you really need them for something, but they're okay.
Great talk.
See you later. Next week will be more fun, I swear. Any more questions? I'm trying to think of a good way to spend the rest of my time that I actually have to leave. I should have left 10 minutes ago. Okay, you know what? I have an idea. Let's say that plus time. Is it underscore time? Lowercase? No, uppercase. Yeah, fun. Sine time times 0.000001. Hopefully that's low enough. Okay, it's too low now. Come on. Do the thing! There we go. So, yeah. Let's see. The fun thing about animation inside of a shader is that it's not actually moving the object. Like, yeah, you're just moving the vertices. So I'll teach more stuff like that next time. Essentially, learning the functionality of CG is really, really handy because a lot of this is math, but it's not math like in high school where it's like, okay, time to do long division. The computer already handles the math for you. Fuck thinking about it. You just need to know what the end result should be. And if you know what the end result should be and what you want it to look like, you can get results that work for you. So, like, I could have done, actually, oh gosh, I wish I had a noise texture. Wait, I kind of do. Alright, you know what, let's see if this works. It shouldn't work, but let's see if this works.
Is there a random function?
There is no random function. Noise on the GPU is fairly frustrating to get around to, but let's see. Noise. Let's see if it lets me do that. I have a feeling that it's really not going to let me do this, but I want to try at least. This is probably going to look very wacky. Oh my gosh, why are you adding in all of these returns? Why did you do this? Why would you do this to me? Stop it. Get back in line. No! Alright. Is equal to... No, there is not. Undeclared I at line 45.
So
Oh.
if visually our object works in a weird way, then the actual collision has to be accounted for in some other way.
Gone. I guess it's not gonna let me do that. Cannot map expression to VS4 instruction set on line. What is that? 44? Alright. I guess it's not gonna let me do that.
Is it XYZ value?
it's a float 4, so it should have it. I'm just curious why it's not letting me do that. Whatever. See you later. Good night. The thing I was trying to do, and I'm sure I could do this with given enough time and seconds, is essentially I was trying to take the texture value of the object and then essentially modify the vertices based on that texture. So essentially I'd be taking like, hey, you know what? I'm sorry, Google time. Getting texture in vertex shader. How to sample a texture in a vertex shader. Text 2Ds. It's only allowed in the fragment. Blah blah blah. You must use text 2D LOD. All right. Well. No matching parameter intrinsic needs some kind of. All right, this is a little bit over my pay grade right now, but either way, I think I'm done. I hope. How many of you will have problems if I move this to 6:30? No one? Okay. I'll probably be doing this next workshop at 6:30 next week. Also, I highly suggest you just talk to me if you have any shader questions, because me giving this demonstration was a little bit dense, and it might be better to just talk to me one-on-one for this kind of stuff, speaking honestly. Also, my throat hurts. I don't like talking this long, despite what all evidence and proof shows. So yeah. This stuff is up on the GitHub if you want to look at it. I even am pushing a new, essentially word-for-word example of what I just said about the vertex shaders. Word for word, essentially. And next week we'll do something a little bit more fun. I'll probably go through noise, textures, time, some of the stuff that I did for Capstone to make things more helpful, screen space texture mapping, and a lot of other really helpful actual effects to help your games kind of immediately. And then probably the week after that, but it's very hardly noticeable unless you really look for it. So that's pretty much it. That's my shader workshop. Please clap. Thank you. That took too long. That took way too long. Let us begin.